This is the Your Turn number 2 in section 4.4. We are trying to find the equation of the normal line to the following curve. So before we can find the equation, we do have to determine the slope. Before we can determine the slope of the normal, we do have to find the slope of the tangent line. Since the tangent line and the normal line are perpendicular, we know their slopes are opposite reciprocals. So we're going to use the definition of the derivative to determine that slope of the tangent line. So the limit as h goes to 0 of f of x plus h minus f of x divided by h. So to determine f of x plus h, we are going to sub in x plus h wherever we see an x. So we will get x plus h minus x plus h cubed. Now we're going to have to expand this out. And then what we are going to do is sub it back into our definition of the derivative. So f of x plus h is going to be x plus h minus x plus h cubed. But then we have to subtract again from the original, which is x minus x cubed. So there's quite a bit of expanding here that we have to do. So I'm going to do that on a separate page so that we can see what we're doing. And then we can substitute all the values back in. So we have x plus h minus x plus h cubed minus x cubed. So let's work this out. We have to multiply this out 3 times. So I'm going to multiply the x plus h 3 times with that binomial. This is a little bit of work. Then I have x plus h minus, I'm going to keep the first binomial and multiply out the 2. So I have x squared 2xh plus h squared. I'm going to put brackets around that. I'm just doing all my workings on this so that I don't have to keep doing step by step. So I multiply out again. So I'm going to have x cubed 2x squared h xh squared. Then I'm going to multiply the h through. So I'm going to have x squared h 2x squared, sorry, 2x, try that again. I'm going to have 2x h squared plus h cubed. Still got to subtract that at the end. So then I have x plus h minus all of this. So I'm just going to rewrite it all. X cubed, 2x squared h, xh squared, x squared h, 2xh squared minus h cubed. And this subtraction here is going to make the x negative and the x cubed positive. So what I notice is that the x cubes are going to cancel, the x's are going to cancel as well. And then I have those terms remaining. So I'm just going to go back and plug all those terms in. So I have f prime of x equals the limit as h goes to 0. And again, I just did all these 3 steps just previously. So I had a h minus 2x squared h minus xh squared minus x squared h minus 2xh squared minus h cubed all over h. They all have h's, which is good because then I can cancel with the denominator. So if I take a h out, I'm left with h minus 2x squared minus xh minus x squared minus 2xh minus h squared all over h. So the h's are gone, which is your monomial term. Then I'm left with a h here. I'm left with a h here, but that's going to go to 0 as you apply your limit. This, sorry, this is supposed to be a 1. Sorry about that. I'm taking h out. So then I'm left with 1 minus, these two are like terms, so I'm left with 3x squared. This h is going to go to 0, so that's gone. So my derivative is 1 minus 3x squared. Now the derivative at the coordinate 1, because x is 1, is going to give me 1 minus 3, which is negative 2. Now this is your tangent slope. However, they asked me for the normal slope. So remember that the tangent and normal are perpendicular to each other, so they have opposite reciprocal slopes. Therefore, the normal slope is going to be positive 1 over 2. So now I'm going to write the equation that they asked me to find. Y minus y1 equals mx minus x1. Again, the y coordinate was given to be 0. The slope of the normal I found to be a half, and the x coordinate was 1. And that's the same thing as a half x subtract a half.